Hello guys, let's quickly talk about Math 101. Math 101. So we are going to discuss complex number. Complex number. We just saw a few questions on it. Just few questions. Now, complex number. When we are talking of complex number is a combination of real number and imaginary unit. For instance, if we can have something like a plus ib or bi. So this is the real part, while this is the imaginary part. Where that I is imaginary unit. You cannot see it on the number line. You cannot see it on the number line. For instance, if I say what is the square root of roots? What is the square root of minus 2? If you have an even root of negative number, so that's where the issue of complex number comes in. So since this one doesn't have a direct answer because there is nothing that you will multiply by itself twice that is going to give you minus 2. Like, you can't multiply any number by itself twice that will produce minus 2. So you can split this guy to root 2 multiplied by what? Root minus 1. Are we together? Where root minus 1 is the imaginary unit I. Root minus 1 is always I. So now we can say root minus 2 equals to what? Root 2I. So that's that. So root minus 1 stand for what? Root minus 1 stand for I. Take note of that. It's like a constant, like root minus 1, it stands for I. So now, what we are going to do now is, if you have I square is minus 1. How do I get that? If root minus 1 equals to I, now square both sides. If you square this and square this, yes, square cancel this root. That means I square equals to what? Equals to minus 1. Are we together? So I square is minus 1. Take note of that because what we are dealing with today for now, this basic. So I'm not going to move to some aspect that we need this I square what I want to calculate. So that's why I'm just showing us this. Because if we say root minus 1 equals to I, we square both sides, then I square, because this one we cancel the root, I square produce minus 1. So that's that for that. Now let's move to few questions. Let's say find the real and imaginary part of let's say 1 plus 7i divided by 3 plus I. We want to find the real and imaginary part, meaning that our final answer should be in form of this, whereby we have the real part and the imaginary part. So how are we going to deal with this guy? We are going to rationalize, just like sword, rationalizing by the conjugate of either the numerator or the denominator. But I think this would be much more easier by using the denominator. So this gives us what? 1 plus 7i divided by 3 plus I, divided by 3 plus I, multiplied by 3 minus I, divided by 3 minus I, using the conjugates. Are we together? So I times 3, what do we get? We get 3. 1 times 3 rather, we get 3. 1 times minus I, we get minus I. 7i times 3 plus 21i. 7i times minus I minus 7i square. Do we get that? 1 times 3, 3. 1 times minus I. 7i times 3, 21i. 7i times minus I minus 7i square. Divided by 3 times 3, that's 9. 3 times minus I, that's minus 3i. I times 3, that's plus 3i. I times minus I minus what? I square. Are we together? So at the end of the day, we are going to get something like this equals to, we have 3 minus I plus 21i. That's plus 20i. That's plus 20i. This minus 7. What is I square? You know, I told you earlier that I square equals to minus 1. I proved it to us earlier. So divided by, now these two cancel. So we have 9 left. 9 minus, what is I square? Minus 1, right? 9 minus I square, and I square is minus 1. So now at the end of the day, we are going to get something like equals to, now here we have 7 minus 7 times minus 1, that's plus 7, plus 3, that's 10. 10 plus 20i divided by what? 9 minus minus 1, that's 10. Do we get? So at the end of the day, this will give us what? 10 divided by 10 plus what? 20i divided by what? Divided by 10. 10 over 10 plus 20i divided by 10. So what do we get? 10 over 10 is what? 1 plus 20i over 10 is what? 2i. So this is the final answer. So the real part now is the 1, while the imaginary part is the 2i, just like this for. So that's that for that. Now let's treat another question. You can split this 10 into each denominator. That's what I did here. Then you get this. But always know that your I square equals to -1. I've shown us that in the beginning of the video. Now let's see another question. Let's see another question. Let's say we have question like this. Let's say we have we want to express a square plus 7b square as a product of two complex numbers. Express a square plus 7b square as a product of two complex numbers. So we want to express this as a product of two complex numbers. So please take note, x square plus y square equals to x plus iy x, so minus iy. Now normally this looks like different of two square, which should be minus, but in terms of complex number, this guy equals to this guy. Just know that. Now let's check. X times x, you have s square. X times minus iy, we have minus ixy. Iy times x, we have plus ixy. Minus m plus iy times minus iy, we have minus I square y square. So these two cancel out. So here, what do we have left? S square minus, what's I square? I square is -1. So we have y square. So here we have s square minus times -1 plus y square. So this guy equals to this guy. Take note of that. So that's all we want to do now. So here, since this equals to this, so we want to write this in that form: a square plus 7b square. Don't forget, you can write it as a square plus root 7b all into square. Yeah, because root 7 square will give you 7. B square will, so this guy equals to this. Now this guy look like x and this root 7b look like y, so we can express this in form of this. So at the end of the day, we get x, that's a, plus iy. What's our y? Root 7b. Then x, that's a minus iy. Root 7b. So that's the answer. I'm just trying to write this in form of something square plus another thing square. So because this square is only with b, and we need square to be on both because these two are together. So for me to still maintain the original question, and since I have to square 7, I have to put root. So root 7 square will still give me this 7 back. So this now look in form of s square plus y square. So I can now put x plus iy, s plus iy. This is my y now. X minus iy, this is my y now. So this is the answer. I've expressed this guy as a product of two complex number. So this one complex, another complex. So that's the product. So that's that for that. So here's another question. We want to write this in form of x plus iy. How do we write this guy in form of x plus iy? Now let's open the bracket. 3 times 2, that's 6. 3 times minus 3i, that's minus 9i. 4i times 2 plus 8i. 4i times minus 3i minus 12i square. So this gives us 6 minus 9i plus 8i, that's minus I, right? Minus 12, what's I square? Minus 1. So this gives us 6 minus 12 times minus 1, that's plus 12. Then we have minus I. So this gives us what? 18 minus what? Minus I. So this like our 18 now is x. This our I. Our plus. You can change this guy to 18 plus minus I if we decide. So that it will look like x plus something. So our 18 is x. Then our I, this is it. Our y here now is just 1. Are we together? So we've write it in the form of x plus what? I, y. So that's that for that. Thanks for the video. Don't forget to like and subscribe. See you in the next video on that complex number. Thank you.